All right, guys, so this is lesson 20. We have more logs that we're working on, okay? Who says this? Tell me the truth. Who says, so far, so good with these logs and exponentials? Raise your hand, like I feel good. Okay, good. Now, I wanna talk about something else. Everybody just kind of kick back and watch for a second. You guys, there are graphs that you have to have memorized. They're called parent graphs. Here's an example, the graph of the parent parabola, okay? So, you have a dot at the origin, right one up one, left one up one, right two up four, left two up four. Oops, didn't mean to do that. So anyway, it has the general shape of that. When you get into 1050, we're also going to memorize some cubics. You're going to memorize how to graph a square root. You're going to memorize how to graph an absolute value of x. My guess is you probably know a lot of those already. So another one that you're absolutely just going to have memorized is an exponential. Okay, for example, y equals 3 to the x power. So this is something that we did last time. So y equals 3 to the x is an exponential. You have an asymptote right there. The asymptote is very important, guys, okay? 0, 1 is a point on the graph. Right 1, up 3, graph it in. There's your exponential. Who says I totally get that? Raise your hand. I'm absolutely good. Okay, look at this. So a log graph is another one of those parent graphs that you're going to have memorized. So for example, y equals log base 2 of x. So here's the deal on logs, okay? The word log begins with the letter L. The letter L looks like that, which is a vertical line. So a log has a vertical asymptote right there. Another property about a log is it always hits the point 1, 0. A parent log always hits the point 1, 0. And then look at that. Sorry, see that number? If you put your pencil at the origin, if you go right, whatever that number is, then you go up 1 and you draw in your log, and that's all you need to know. So it's just as easy as exponential. The properties are different, but it's no different. It's very similar to a 3 to the x power. So this is just another parent graph that you're going to have the properties memorized. Who says I understand what you're saying to me? Raise your hand. Okay, great. So right here is a parent log graph. I want you to write down the word parent. What does parent mean? Parent means you don't have any adjustments, okay? Don't write this down. But I just want you to understand, if I have negative log base b of x plus 2, or let's say log base 4 of x plus 2, that is not a parent log graph. It's not a parent because you've got that plus 2 and that negative that changes the graph. So these properties I'm talking about right here, there's no plus 2, there's no negative, it's just the log, the base, and what you're taking the log of. Who says gotcha? Let me see up high. Great. Okay, so look at this graph. I want you to take your pencil and I want you to dash it in right there. Okay, every single person in this room, tell me what axis that red dash line crosses. Is it x or is it y? It is x. Everybody write x equals. Where does it cross the x-axis, you guys? At 0 is correct. Okay, now I want you to look at the graph and I want you to remember that domain means x. Everybody look right here. Here's your x-axis. You're going to start small. You're going to travel and you're going to find the first place that you hit the graph. The domain is everything to the right of the y-axis, which just means all of the positive x values. So the domain would be from 0 to infinity. Infinity is always closed with a parenthesis. Somebody tell me how I would close that 0. Is it a parenthesis or would it be a bracket? It is a parenthesis. Why not a bracket? It's never going to touch it, because it's an asymptote, right? Okay, look at the range. Range is y. Start low and then move your way up. To everybody in the room, tell me out loud, what's your range? It is everything. All real numbers. I heard people saying negative infinity to infinity. Those are all the same things, okay? The x-intercept is right there, bless you, and that is the ordered pair 1, 0. There's your equation, y equals log base b of x, okay? Off to the side of this graph, I want you to do this. I want you to go 1, 2, 3. okay? Here are the 3 things that you need to have memorized about a log graph, okay? The asymptote is x equals 0. It always hits, see that point right there? It always hits the point 1, 0. And then the 3rd thing you need to remember is b, 1. Look at the equation, you guys. It's log base b of x. So whatever that number is, 1. You guys, that's from the origin. So everybody look right here. If I put my pencil at the origin, how far did I go right before I went up 1? That would be 2. So I know the equation of this graph has got to be y equals log base 2 of x. That's it. Okay? Who says gotcha? Let me see. Okay, good. Let's graph some. Y equals log base 2 of x. You guys, the table's silly. It's silly. I don't need the table because I can graph this very quickly without the table. Okay, so let's just go ahead and ignore the table for a second. So this is y equals log base 2 of x. So I know it's a parent log. So I'm going to have an asymptote right there. I'm going to put my pencil right there at 1, 0. Look what people do. Okay, don't do this. Pencil on the dot, right 2, up 1. That is not where you start. It's from the origin. So from the origin, right 2, up 1, curving in, and there I go. Literally, you're going to be able to graph that thing in 20 seconds because it's just three things you have to remember, okay? Who says, I understand, I'm good, I gotcha. Okay, good. Everybody look at the domain, okay? There are 25 people in this room, so I want 25 voices. What's the domain? 0 to infinity. Tell me how to close my 0. Parenthesis because it's not going to touch it. Range is y. Start low, move up. What is it? All real numbers. Asymptote. Everybody in the room. X equals 0. X-intercept is that point right there. Yep, 1, 0. Okay. Y-intercept. Talk to me about y-intercept. There is none. Okay. Okay, I feel like this concept right here is a little iffy in your brain. Okay, listen. For what x values is the graph increasing? Go to the left furthermost part of the graph. That would put me here. This is the furthest left that my graph goes. You know, it'd be really, really low. Look what's happening as I travel from left to right. You tell me, is my graph increasing, decreasing, or constant from left to right? What did my finger just do? Tell me. Increased. Okay. So where did the increasing begin? It is not negative infinity. What is it? It is 0. Yeah. And even though it doesn't actually increase at 0, we're going to put 0 because it's always parentheses anyway. How long does that graph increase? Until how long, how big on the x-axis? Talk to me. Infinity. Yeah. So that would be from 0 to infinity. Excuse me. That's your answer. Okay? Okay, questions on that? You better go, sweetie. I don't want you to miss your bus. You'll be sad. Okay. So table of values. Have fun, hun. Okay? See you later. Okay, y equals log base 2 of x. Everybody write that right here. Y equals log base 2 of x. So I'm telling you right now, I'm never going to give you a table because the point of a table is to help you graph, but I just graphed and I didn't even need the table. Okay? But what if Weber State gives you a table? I want you to know how to deal with it so we don't miss it, okay? Putting in values into a log is kind of difficult. So I saw a lot of different groups do this. When you started putting the values in, what did you do before you put the values in? Tell me. What did you do? Did you keep it in log form? What did you do? Come on. I saw almost every group do this. What did you do? You converted it, right, into exponential. So everybody write down 2 raised to the other side, which is a y, is equal to x. Now put in those values of y. You don't start with x's, you start with y's. So if y is a 0, 2 to the 0 is a 1. If y is a 1, 2 to the first is a 2. If y is a 2, 2 to the second is a 4. What is a 2 to the negative first power? Tell me, guys. It is 1/2. Yep, there's your table and you're done. Let's do the next one. Y equals log base 3 of x, okay? Look how quickly I can graph this. It's not a race. I'm just telling you how quickly and how easy. Look, it's a log. There's your asymptote. Guys, if your asymptote is on an axis, extend it beyond the axis so I can see it, okay? Then it hits the point 1, 0. Put your pencil at the origin, go right 3, up 1, graph it in, done. Who says this is easy? That graphing is so easy. Let me see. Give me some feedback. Okay, yay. Domain, same as the other one, 0 to infinity. Range, same as the other one, all real numbers. Asymptote, same as the other one, x equals 0. X-intercept, same as the other one, 1, 0. Y-intercept, it's the same, none. Where's it increasing? It's the same. It's always, well, it's increasing on the whole right side, which is 0 to infinity. Okay, let's do a quick table of values. Everybody write y equals log base 3 of x. Then I want you to convert it. So it's 3 to the y equals x. Y is a 0, 3 to the 0 is a 1. Y is a 1, 3 to the first is a 3. Y is a negative 1, 3 to the negative first is, talk to me everybody, 1 over 3. Very good. Okay, this guy right here, people see that and they freak out. Here's my question. Is an ln a log? Yes or no? Is an ln a log? Yes or no? Yes, it is. It's just log base e. Yeah, that's not scary. So everybody write y equals log base e of x. It's a parent log graph. So put your asymptote and extend it beyond the axis. Hit the point 1, 0. Pencil back to the origin. Go right 2.7, up 1, there it is. Very quick, very easy. You just have to remember those 3 things, and then you're golden, okay? Domain, look at the graph. It's the same as the other one, 0 to infinity. The range, all real numbers. Asymptote, x equals 0. X-intercept, 1, 0. Y-intercept, none. Where is it increasing? Let's write it the other way. Let's say x is greater than 0, which is the same thing as 0 to infinity. Okay, let's fill in the table. Let's convert it, you guys. Everybody write e to the y is equal to x. If y is a 0, e to the 0 is a 1. Y is a 1, e to the first is an e. You guys, what is e to the negative first power? What is that? 1 over e. Yeah. Just bring it down to the bottom, and now it's a positive exponent, and that's good enough for me. Okay? All right. Let's find the inverse. Okay? How do you find an inverse? What do? Do you guys remember? How do you find an inverse? Okay, I'm going to tell you. Write down switch x and y is the first thing you do. The second thing you do is you solve for y. Okay? Everybody freeze right there for 2 seconds. I want to talk to you about something. Okay? You have to understand this to be able to do this problem. Everybody look right here. Log base 3 of x equals 2. Stuck. Stuck means the log is alone on whatever side of the equal sign it's in. So see this log? Do you see this 3? The 3 is part of the log. Some people think that you can divide by 3 right here to get rid of the 3. They're like, oh, I'm just going to divide by 3 and the 3's go away. You can't do that. Just the way you can't do this. Look, the square root of x plus 1 equals 4, minus 1, the square root of x equals 3. Everybody in this room knows you can't do that. And this guy right here is the exact same concept. Bless you. The 3 is part of the log. You can't do anything to it. You can't divide by x. It's stuck to the log. So this stuff right here is all stuck together. Okay? When you look at that, here's what your brain needs to see. Y equals 2. Because that log base 3 of x is one thing. I'm stuck. So when I'm stuck, I convert. So look what I'm going to do. I'm going to write this as 3 to the second is equal to x. So my answer would be x equals 9. Who says I understand all that you just said? Okay, look at this right here. Log base 3 of x minus 1 equals 4. Right there. Am I stuck? Tell me, everybody. Is the log all along? Everybody in the room, 25 of you. Is it along? No. So am I stuck? No. What do? Move your 1 over. So now I would have log base 3 of x is equal to 5, and now I'm stuck. And now I would convert, so I would have 3 to the 5th is equal to x, and that would give me some big number, whatever 3 to the 5th is. Who says I understand what you're saying? Good. Okay, let's come back over here. Find the inverse. Make your x a y, make your y an x. So everybody write down log base 3 of y is equal to x. I'm stuck. Because the log is alone, the 3 is part of the log, the y is part of the log, I'm stuck. So I'm going to convert it. So I'm going to write it as 3 to the x is equal to y, and guess what? I'm done. You guys already figured out during that class activity time that the inverse of a log is an exponential. That's why. If you convert it, it's just, switch them and then solve for y, then it's an exponential. Okay? Okay, find the inverse of 9 to the x equals y. First thing you have to do is switch your y's and x. So everybody go 9 to the y equals x. Why do you do that? Because that's how you find an inverse. And now I'm stuck. Look right here. I'm stuck. Here's my base. Here's my exponent. There's nothing else over there. If I had this, everybody look right here. If I had 1 plus, I would not be stuck. I would have to subtract 1 from both sides. But I don't have that. So it's just my base and my exponent, and I'm stuck. So now I convert it. Everybody write log base. Log base what? All 25 of you. What's my little number that goes there? 9. Of, talk to me. Of the other side. Remember, log base 9 of the other side, which is an x, is equal to y. There's your answer. Done. Just convert it. Okay? Okay, question 4. Find the inverse. Find the domain, find the range, write the equation of the asymptotes, blah, 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 blah. Okay, I'm going to give you steps. Here we go. Step number 1, I want you to graph f of x. Okay, so everybody write down y equals 4 to the x power. You should know how to do that perfectly because that's what I taught you last time, was an exponential. Everybody freeze right here for 2 seconds. Freeze. Here's where people get confused. Y equals 4 to the x. Does that have a vertical asymptote or does it have a horizontal asymptote? Everybody in the room tell me. Horizontal, because it doesn't start with an L. L is this, so it's this. So remember, everybody do this right there. It hits the point 0, 1. And now this is last time's lesson. From that origin, if I go right 1, I go up, tell me everybody. Up 4. Good. Draw it in. There's my graph. Okay. The second thing that I want you to do is I want you to find the domain and the range of f of x. Okay. Look at the graph. Domain. Everything. Look at the range. Start low. Come up. It's everything above the x-axis, which is 0 to infinity. Okay. The asymptote, that dashed line, hits the y-axis at 0. Okay? The third thing that I want you to do is to switch the D and R, domain and range, of f of x to range to the negative first and domain to the negative first. Let's just leave it right there. You guys, if you switch the x's and y's, the domain and the range switch. This is so important. Look, the domain here becomes the range here. Why? Because the x's became the y's. The range here becomes the domain here. Why? Because the y's became the x's. So it looks like that. Okay? Who says, I understand? Raise your hand. Let me see. Up high. Okay, great. Step 4. I want you to graph the line y equals x. That's the next thing I want you to do. Looks like that. Step number 5, I want you to graph the inverse. Imagine folding that thing in half. Okay, you guys look at that f of x. Let's put in a few values. So f of x is 0, 1, and then 1, 4. Let's do one more. What if x was a negative 1? Then 4 to the negative 4th, or negative 1st, would be 1/4. So the inverse is switching those. So 0, 1 becomes 1, 0. 1, 4 becomes 4, 1. 1/4 negative, or negative 1 comma 1/4 becomes 1/4 negative 1. But guess what? You don't even need that table. Okay, look at this. See the distance that point has? Actually, you know what? I don't even want to do that. Let's just plot those points. Everybody plot the points. 1, 0, 4, 1, and that's enough. You guys know that this thing is going to be a log, right? Looks like that. Don't forget the asymptote. Looks like that. Okay, and then question number 6, I want you to write the equation for f inverse of x. Look at the equation. Y equals 4 to the x. Everybody switch your x's and y's. X equals 4 to the y. Now I'm stuck, so I convert it. So it would be log base 4 of x is equal to y. But I'm not going to put equals y because the notation for the inverse is f to the negative 1st of x equals. Okay, so that's just saying find my inverse. So they want us to write it on that line, log base 4, put in equals right there, log base 4 of x, and there's your whole deal. Last year was only the second year this course was taught, and they did ask us to fill in a table of values. So just remember, whatever the x is on the regular goes to the y, whatever the y is goes to the x, and they all just switch. Okay, who says I totally get this? Raise your hand, let me see. Okay, yay, doesn't that feel good? Okay, question 5. Is a log an inverse? Yes or no? Is a log an inverse? Yes, the answer is yes. And I'm going to say a log is an inverse of, finish my sentence, an exponential. You're exactly right. An exponential. Okay? All right. Remember how I told you logs were easy and that you shouldn't hate them and you shouldn't be afraid of them. You just have to memorize the rules. Here's 3 more rules. Okay? So you have got to memorize these. Okay? Product property. Okay, everybody write this down for me. Log base A of BC. In parentheses or not in parentheses, it doesn't matter. Up above that, I want you to put condensed. And to the right of that, I want you to put expanded. When you expand a balloon, you guys, it gets big. Condensed soup is soup that's like all squished in. Okay, so condensed is squished in, expanded is out. Okay, so look, product means multiply. So if these two things right here are multiplied, then when I expand them, does anybody remember what you're supposed to do from last year? You add. So here's the rule. It's log base A of B plus log base A of C. Let me give you an example. Come off to the side, put EX. Everybody write down log base 2 of 3x. If they asked you to expand that, the 3 is multiplied by the x, so that would be log base 2 of 3 plus log base 2 of x. That's it. So if they're multiplied and they're squished, when you expand, you add. Okay? Here's the next rule. Quotient property. Okay? Write this down. Log base A of B over C. A quotient is a solution to a division problem. So B and C are divided. So when you expand that, you write it as log base A of B. Does anybody remember what to do? It is subtract. Good. Subtract log base A of C. So multiplied means add. Divided means subtract when you expand. And the other one is a power property. You already know this. We already talked about this last time. Look, if you have log base a of b raised to the c power, what do you do with that exponent? Do you guys remember what to do? Pull it in front, right? So it's c times log base a of b. So you guys already knew that one. Okay? Okay, let's go ahead and do question number 6. Okay, 6a. Everybody freeze right here for 2 seconds. Don't write anything, okay? I'm taking the log of 3 things. Look, a 2, an x, and a y. So I know right now I'm going to write log 3 times. And if they're multiplied, then when I write it those 3 times, I add those together. So this is just going to be log base 2 of 2 plus log base 2 of x plus log base 2 of y. Now, if you write your answer like that, you're not going to get full credit because there's something else that you can do. We learned it last time. What is it, Miranda? What is log base? It does cancel out, but what does it equal to? It's equal to 1, yeah. So this is 1 plus log base 2 of x plus log base 2 of y. That's your answer. Okay? Everybody stay right here with me on B. Okay? Please don't go ahead of me. There is 0 benefit to going ahead. Just confusion. That's what you're going to get. Can you tell me how many times to write the word log right here? 3. 1 for the 4, 1 for the x, and 1 for the z. You can do this the easy way, or you can do it the hard way. Okay? You got to trust me. Look. 4 is on the top. He's a positive. The x is on the bottom. He's a negative. The z is on the bottom. He's a negative. So remember, divide means subtract. So anything on the bottom has a negative sign. It's so easy. So look, you just go log base 3 of 4 minus log base 3 of x minus log base 3 of z, and literally you're done. That's all you have to do. You just have to remember the rules. Okay? I want to ask you a question. Every single time I teach this, people say this. Actually, you know what? I just want you to look. I want you to watch. Here's an explanation. Don't do it like this. But here's an explanation. Okay, look. Just kick back and watch. Log base 3 of x minus the log base 3 of x times z. When you divide, you subtract. Okay? These are multiplied. So when I multiply, I'm supposed to add. So see that negative? It's going to be negative, and then it's log base 3 of x plus log base 3 of z, because when you're multiplied, you add. But now you take that negative and distribute it, and it changes the signs. But guess what? You don't have to do any of that. So just make it easy. Bottom, negative, top, positive, done. Who says gotcha? Let's see. Great. Okay, let's do the next one. Question C. This one's easy. What do? Everybody in the room, you should know this. What do? Pull down the 3. Sure. So it's just 3 times log base 2 of x, and you're done. That's it. Okay, here's question D. Nobody move yet. Nobody write. All 25 of you, how many times will I write the word log? Tell me. 3 times. 1 for the x, 1 for the y, 1 for the z. Okay? Everybody write log base 3 of x to the 3rd plus, when you multiply, you add, log base 3 of y to the 2nd plus log base 3 of z. Now, that is not the answer. It is not fully expanded. Why not? You can say it with one word. Why not? Those exponents. Yeah, pull the exponents down. So this is 3 times log base 3 of x plus 2 times log base 3 of y plus log base 3 of z, and I'm done. Okay, this guy right here. Does an ln follow the rules of logs? Tell me that. Yes, because an ln is it's a log. How many times am I going to write ln? Tell me, everybody. 3 times. How many of those 3 times that I write ln is my ln going to have a negative sign? Once. Which one? The x. Yeah. So this is ln y to the second plus ln square root of z minus ln x. Everybody freeze for a second. See that square root of z? I want you to erase it. Because the square root of z is the same thing as z to the, I feel like you don't know this answer, z to the, tell me, 1/2. Yeah? Inside exponents of 1, little numbers of 2, 1 over 2. One word that tells me why I'm not done. Exponents. Yep. So it's 2 ln y plus 1/2 ln z minus ln x, and I'm done. Look right here for a second. Who says this? I understand. Raise your hand. I understand. Okay, all you have to do is know the rules. I know it's annoying because I say it 5 times every day, but it's true. With logs, know the rules, and you're home free. That's all you have to do is know those rules. Okay? Okay, now we're going the other way. Now we're going to squish it together. So we have to go in the opposite order of what I just did. Someone tell me what to do first. 1/3, talk to me, Weston. Bring it up. Yeah, the 1/3 comes up and the 5 is going to come up. So this is log of x to the 1/3. But guess what? I don't even want you to write it like that. X to the 1/3 is the same thing as, tell me, cubed root. Yeah, little numbers of 3. Inside you have an x to the first. And this is plus the log of x minus 3 to the 5th. Now I'm going to squish it. When it's condensed, do this, right? Circle that word condense, and I want you to write this down. Write, in quotations, put log 1 time. You would never say log in something that's condensed. It's a single log. Okay, so look at these guys. Those are added, so when I squish them together, they're going to be, what is it? They're going to be multiplied. It's just the other direction. So this is a cube root of x and x minus 3 to the 5th. That looks horrid. I hope that you look at that and go, that is bad and it's complex. So if what you're taking the log of is complex, you guys, add brackets or add parentheses. And that is much more clear to see what you're taking that you're taking the log of all that stuff. Okay? Okay, let's do question B. One word. Tell me the word. Just one word. That's all I want from you. What's the word I'm looking for? Exponents. So this is the ln of x minus 4 to the 4th minus the ln of x squared. Now I'm going to write ln one time. Are those things going to be multiplied? Are they going to be divided? What is it? They're going to be divided. Which one goes on the bottom? The x squared, because he's the negative. What one goes on the top? Anything that has a positive sign, which is x minus 4 to the 4th. Looks like that. Don't do this. ln of x minus 4 to the 4th over the ln of x squared. That is not writing the log one time. That's writing the log 2 times. Do me a favor, grab your pencil, add brackets right there. Make it look clear because it's so complicated. So make it clear. Okay? Okay, here we go with question C. Pull them up. So this is the log of the square root of x. X to the 1/2 is the square root of x. Plus the log of y to the 4th minus the log of 4 minus the log of p to the 6th. Now I'm going to squish it into 1. Anything that has a negative exponent goes on the bottom. Anything that has a positive exponent goes on the top. So the square root of x has a positive exponent. He goes on the top. The y to the 4th has a positive exponent. He goes on the top. The 4 and the p to the 6th are both negative. They go on the bottom. Done. Easy. This is easy. If you just know the rules. Who says, yep, that's true. This is all right. Let's see how we're doing. Give me some feedback. You okay? Okay. All right. Question D. All right, so first thing I want you to do is this. You guys, do you see how this is log base 2? Sometimes the author of this problem is trying to get you to write it as log base 2 of 2. Now, if I had log base 2 of 7 in there somewhere, I can't write I can't write a 7 as a 2 to the something. So this guy, I could never do it, but you should try. Why did they want you to write it as log base 2 of 2? Because log base 2 of 2 is a 1, and then it just becomes a 1. It just goes away. So look at the 8. Everybody write down log base 2 of x minus 1 squared minus log base 2 of 2 to the 8 is 2 to the 3rd. Okay? Then just keep going. I'm obviously not going to be able to write an x as a power of 2, so I'm just going to write that the way it was. And then this is plus log base 2 of 2 to the 3rd. Now look what we've got. We've got log base 2 of 2 to the 3rd and negative log base 2 of 2 to the 3rd. Those are exactly the same, but one's positive, one negative. That becomes a 0. So now I have log base 2 of x minus 1 squared plus log base 2 of x. I'm not done condensing because I've written log more than once. Those are added, so when I squish them, they're going to be multiplied. It's typical to put the x in the front and then the x minus 1 squared behind it. I'm going to add brackets, then I'm going to highlight it, and that's my answer. You're going to do logs in 1050. 2 guys, check this out. We're almost done. We're almost done. We've done this. I'm just going to go right to this example 8. I talked to you guys about this. If you don't have log 10, how do you do it on your calculator? Everybody go log 30 divided by log 4. To the directions, I want you to add the words 4 digits. You're never allowed to round unless they tell you to round. So we're adding to the directions to round. Unless it's money. Money you always round to the nearest cent, okay? Everybody go log 30, close it off, divided by log 4, close it off, enter. 4 digits is 2.4534, done. Okay, let's do this guy. This is log 14 divided by log 2. You have permission to round. You have a permission to write your answer in an imperfect manner. Never do it unless you have permission. Log 14, close it off, divided by log 2, close it off. Your answer is 3.8074, box it, and you're done. Okay? Who says I'm good? I feel good. I understand. Give me feedback. Hello, I'm talking to you. How do you feel? Good? Okay, great. Okay,